here's a beaker full of water. Let's talk about what kind of pressure we want, right? Actually, I want the pressure right here. So, all right, there we go. So let's take a look at pressure while looking at the depth in a static fluid. All right. So let's get this out of the way. So let's do some review first. Pressure is force over area. Density is mass over volume. And now let's see, what else do I need to know? Pressure, I got depth, and I think I'm going all right. So let's go back to our beaker here for a moment. So here we are. Here's our beaker full of water. I'm going to back out here for a second. There we go. Now I want to figure out what is the pressure at some arbitrary spot. So let's pick this place right here. Here's my little cube of water here. All right, and I want to find out what's the pressure at some arbitrary point here. This has some height h, and on this my little cube of water inside of there's this pressure coming down from above. We'll call this pressure 1. There's some pressure underneath coming underneath. We'll call that pressure 2. Now let's do a free-body diagram of this little box. Where's my, let's pick a color. Let's pick this one. So here's my little box. Forces that are on it. Well, my little box is not accelerating, so the sum of my forces on it equal ma, but ma equals 0, so the sum of my forces on it are 0. What do I have on it? Well, I have the force of gravity on it, and it's pulling down. I have pressure 1 pushing down, the force due to number 1 pushing down, and I have pressure 2, the force due to pressure 2, I'm going to call that F2, pushing up. But pressure is force over area, so the pressure is, or I'm sorry, the force is pressure times area. So F2 is just pressure 2 times the area, which is this little space down here. There's a reason I picked a cube. F1 is P1 times area. Let's sum these forces up. Make this way positive. So we have F2 minus F1 minus Fg equals 0. F2 is P2A minus 1, P1A minus the force of gravity, which is mg, equals 0. What's my mass of my little piece here? Well, I'm not sure, but oh, look. Mass is just rho times the volume. So, let's see, P2A minus P1A minus m, which is rho v, rho vg equals 0. But what's my volume of this thing? The volume is this area on top times the height, is the area times the height. So let's keep going. So I've got P2A minus P1A minus rho v, which is AH, AHG equals 0. Oh, look, A, and 0. The A's cancel out, so I end up with P2 minus P1 minus rho HG equals 0. Move some things around. P2 equals P1 plus rho. I'm going to move these two around. GH, because this is the form that it's in on your equation sheet. So let's take a look at what this means. This is the pressure, P2, in a static fluid. Notice the fluid's not moving. It's this thing. Now, this only holds true if there is no change in rho. So for liquids, that's generally true. Gases, kind of true, provided delta H, my height of the thickness of my little chunk here is small, provided my delta H is small.